Hello students, so welcome to today's video. We are in the period of straight lines, optional math portions, class 10. Okay, so it's been a long time, so okay. There was some of the work, personal work, which I got entangled into. So it's a break, a long break. Okay, now let's go into the exercise 8.2, page number. I think page number 179. Yes, page 179. 179. Vedanta. Vedanta axle. Okay. So this one is the optional math portions. So a lot of the students, they were asking about the what is homogeneous equations. So homogeneous equation is nothing more than the having algebraic terms and each terms having the same degree. Okay, for example, let's take some algebraic expression. For example, 2x plus 3y. So this is an algebraic expression, and you can see here they both have the same degree, 1 and 1. So the degree is in its terms in the algebraic expression is same. So this is also homogeneous equations. Now if I take 2x squared plus 3xy plus 4y squared. Now in this case, here the degree is 2, here also the power of x is 1 and the power of y is also 1. So here also 1 plus 1, the degree is 2 here. Here the degree is 2. So in its terms of this algebraic expression, in its terms they have the same power, 2, 2, 2. Same degree, yes? So this is also homogeneous equations. So in the same way, just if I take 2xy square, 3y cube, and x cube. So in this case also you can see here square, y square plus 1 power x power 1, 2 plus 1, the degree is 3 here. In this case also degree is 3, in this case also degree is 3. So in its algebraic terms, in its terms of the algebraic expression, this algebraic expression, they all have the degree 3. So in this case also this becomes the homogeneous equations. Now if there was something like okay, for example like this, okay, if I remove the powers, 2 power sign here, and now here the degree becomes 2, and it is 3 and it is 3. So beside these two algebraic terms, these have different degree. You can see here the degree is 2, and the remaining the remaining terms has the degree 3, 3. So in this case, in this algebraic expression, the differ because of this difference, because of the different degree, it is not the homogeneous equation. Either this should be x squared y, it will sum up the power sum up to make the degree 3. Okay, so if they all have the same degree in its terms, in its algebraic terms, if they all possess the same degree, then this kind of equations is called the homogeneous equation. So in words you can write, you can say it like that. Okay, so in its, so whatever the algebraic terms, if they in each terms, if they consist the same power of degree, then that is called the homogeneous equation. So homogeneous equation is nothing. Homogeneous equation is the equation in which the power, or we can also call it and this is in x and y in is terms of equation equal. That is okay. Okay. And so homogeneous equation is the equation in which the power or indices in x and y in its terms of the equation should be equal. Are equal, or whatever, in its terms of the equation are equal. In other words, equation in which all the terms of an equation has the same degree, variables. Okay, the degree must be same, either with the single variable or in combination with the double, triple, or whatever maybe. But the power in its variables of the same equation must be the same. For example, here ax plus x squared plus a squared. So here the degree is 2, here also degree 2, here is also degree 2. So it is a homogeneous equation in terms of a and x. Okay, so for example, another example will be x squared plus 2xy plus, I'll remove this x for now. Okay, x squared plus 2xy plus y squared. So this is also homogeneous equation. You have to equate with 0, otherwise it will not be the equations. Okay, so this is the very simplest how to know what is homogeneous equation. So I would like to give another example also, if there. Okay, so let's see another equations. For example, x cube plus 4x square y plus 3xy square plus y cube is equals to 0. This is also homogeneous equation because here the power is 3, here also the degree, here the degree is 3, here also the degree is 2 plus 1 3, here also degree 3, 2 plus 1 3, and here also degree 3. So they all possess, each terms possess the same degree, so that's why it is a homogeneous equation. So I think you are more clear about this concept now. This one is a very trivial questions, so I would like to move on to the main part, that is exercise 8.2. So I'll be starting number 2, 3. I've written in the left side of the board. Okay, without further delay, I'd like to go into that. Okay, let's move on to the number 2. Okay, so I'm only going to do number 2a. Okay, so this one is a very easy questions. So this one very trivial questions. So we'll start from the basics. So these are the basic terms. So I'd like to start from here. Okay, number 2. You have to find the single equation represented by the pair of straight lines. Here is given pair of straight lines, number 2a. So you will be given 2 pair of straight lines here. Equations are, here are two equations. One is x minus 1 equals to 0. Suppose this is I, and another is x plus y is equals to 0. Okay, so you have to you have to combine these two, which will yield a single equation that represents these both two equations. Okay, so what you do is just multiply equation I and double I. Multiply equation I and double I. So when you multiply x times x minus y times x plus y is equals to 0 times 0, that will be 0. So this will in the form of a square minus b square. This can be written in x square minus y square is equals to 0. So this is the required equations, which represents the pair of straight lines, and those pairs are this: x minus y equals to 0 and x plus y is equals to 0. So these two pairs is represented by a single equation, that is this. Okay, so in the same way I have done 2a, and remaining b, c, d you do by yourself, just like this. So you can, in the end you can write 0 represents the pair of wait, I'll just try to make this language more better. So x squared minus y squared is equals to 0 is a single equation. Is a single equation which represents pairs of straight lines. L-I-N-E-S, L-I-N-E-S, pairs of the straight lines. So this is how it is done. So without further delay, now just the opposite of this. So in 2a, this is 2a, so in 2a we combine both equations to make it a single. Now we have a single equations which represents the pair of straight lines, and we have to conclude that pairs. Okay, and just the reverse of this. So in the 2a we have given two lines, two separate lines, and we combine those two to form this single equations, which represents these two a pair of straight lines. But in the number 3 we'll be given this type of equations, and we have to extract those two equations from this single equations. Okay, so let's move on to number 3 without further delay. So this 2a I have done, and rest you do by yourself. So I'll be doing 3b, c, d. Okay, now we have to find separate equations. Number 3, find separate equations. We have to find separate equations. Now in 3b you can see here 3b, 9x squared minus 25 y squared is equals to 0. Okay, so this represents a single equations which represents the pair of straight lines. So you have to find the pair of those lines. Okay, so given equation is 9x squared minus 25 y squared is equals to 0. Now factorize this. Okay, now this can be converted into in the form of a squared. This 9x squared can be written as 3x whole square minus this can be written as 5y whole square is equals to 0, or 3x plus 5y and another 3x minus 5y is equals to 0. Okay, so now after this you can do either 3x plus 5y is equals to 0 or 3x minus 5y is equals to 0. So these two are the separate here. I and double I are two separate equations of line. Okay, here I and double I are two separate equations of line represented by REPRES and represent by single equation 9x squared minus 25 y squared is equals to 0. So I have made it more lengthier. You can end it up to here. So here I and double I are two separate equations of line represented by the single equation. End it up to here. No need to write this. Okay. So this is how it is done. So I have done number B. If you have finished this, so I'll be doing number C. If you haven't, just take a screenshot and try to copy that later. So let's move on to number C. Okay, I'm going to rub this. So in number C, we have x squared minus y squared plus x plus y is equals to 0. Okay. Here is minus there. Okay, here is minus. So given equation of line is x squared minus y squared plus x minus y is equals to 0. So I'll be trying to rub this. Okay, so the same here, the procedure is same, everything is same. So okay, this one is a very trivial one. Okay, so here try to factorize this. Now you can see here only this part. This can be converted into a square minus b square. What is the formula for a square minus b square? A plus b, a minus b. Now use that formula. This can be written as x plus y and x minus y. So here is already x minus y. Just write x minus y within the bracket to make it easier to take common from here. Okay, so from these two terms you can take x minus y common, and then after the remaining here will be x plus y plus, so this is already gone here, so remaining will be only 1 here. Okay, now we can do either x minus y is equals to 0, take it I, and x plus y plus 1 equals to 0. Got it? Okay, so these two here, I and double I, are two separate equations of line. Okay, so this is how it is done. Now, so after this, let's move on to number D. Okay, D is nothing more than like this. Okay, a little bit you have to work there, only a few. Okay, so without further delay, I would like to move into number D. So if you have finished, then I'll do D now. Okay, so I'm going to rub this. If you haven't, just take a screenshot and try to do it later. Okay, now I have done this. Okay, so all within this part. Okay, so in number D, so we have equations x squared plus y squared minus 2xy plus 2 times x minus 2 times y is equals to 0. So your given equation is x squared plus y squared minus 2xy plus 2 times x minus 2 times y is equals to 0. Here, try to arrange this. Now, you try to look this, try to embed all together these three algebraic terms. So x squared plus y squared minus 2xy, or you can also say like x squared minus 2xy plus y squared. It will go into the formula of x minus y whole square, right? Okay, so these three terms can be expressed in x minus y whole square. Now the remaining is here 2x minus 2y is equals to 0, or so this can be written as x minus y whole square plus, here you can take 2 common, the remaining inside the bracket will be x minus y is equals to 0. Now from here, so here is x minus y squared, here is only 1 times x minus y. So from here you will get x minus y common from here, and the remaining inside the bracket will be x minus y. Here is 2, the 1 is still here. So I'm writing that the remaining x minus y here, and plus 2 is equals to 0. Now you can do either okay, so either x minus y is equals to 0, or x minus y plus 2 is equals to 0. So this is I and this is double I. So equation I and double I represent are the equation I and double I are the two separate equations. Okay, so this is how it is done. Okay, got it. Okay, this one is a very basic and very easiest one, so try to exercise this first, and then you move on to the complex. Okay, so without further delay, I would like to move into the number 4. Okay, so in number 4, you have to show that the two lines represented by the single equations. Okay, the two lines represented by the single equations, you have to show those two lines are perpendicular to each other. So there are two ways for doing this, so I would like to introduce you both. First method is, I would like to what we call that, I would like to first use the slope form. Okay, try to extract the slope of two straight lines. To extract those two straight lines, first you have to factorize this. Okay, so if you factorize this, you will get the two pairs of lines, a pair of lines, not two pairs of lines, only a pair of lines, one and two straight lines you will get, and we'll try to just extract we'll just find the slope of those two lines and use the condition of perpendicularity on that occasions. So, and another method will be just comparing this equation. This is second degree equations, comparing these equations with the x squared plus 2xy plus by squared While you compare those, you will get the value of a and b, and if the sum of a and b is equals to 0, then that represents a pair of straight lines which are perpendicular to each other. So I would like to introduce both ways. So whichever you might more convenient and more effective, you can continue on that. Okay, so let's move on to this. So in number 4a, we have given equation. In given equation we have 3x squared plus 8xy minus 3y squared is equals to 0. Right? So the first method I would like to mention here. In first method, you first find the the separate equations from this. Okay, so let's factorize this. 3 times 3, 9. 9 times 1, 9. 9 minus 1, you will get 8. So here will be 3 3 is 9. 9 minus 1. So xy here minus 3y squared. So I'm here trying to factorize this. 3x squared plus 9xy minus xy minus 3y squared is equals to 0. So here you just take the common. Here 3 will be common and another will be the x variable. So here is only one x here. So from 9 I have already taken the 3. Only 3 remaining here. X already gone. Now y remaining. Here you just take minus y common and x plus 3y is equals to 0. So x plus 3y and another will be 3x minus y is equals to 0. Now we can do either okay, either x plus 3y is equals to 0 or 3x minus y is equals to 0. So this is I and here will be double I. Now try to try to find the slope of both equations. So slope of I. So slope of I, let that be represented by m1. So the formula is minus coefficient of x divided by coefficient of y. So in I you have the coefficient of x 1, and here coefficient of y 3. So here the slope of I is m1 is equals to minus 1 by 3. So similarly in the same way you will get the slope of double I in the same way. Let's that be represented by m2. So minus coefficient of x divided by coefficient of y. Now coefficient of x here we have 3 and coefficient of y minus 1. So in this case minus minus get cancelled, the only remaining is 3. So m1, m2, so m1 we have minus 1 by 3 and m2 we have 3. So lines I and double I will be perpendicular. Okay, perpendicular if what is the condition for perpendicularity? If both slopes are given. So if perpendicular, if m1 times m2 must be equals to minus 1. So in this case try to satisfy this condition. Now m1 we have already 1 by 3 minus 1 by 3 and m2 we have 3 is equals to minus 1. 3 3 gone, the remaining is minus 1 is equals to minus 1, which is true, which satisfy, you can also write true, or which satisfy the condition while if the condition is satisfied, it is proved. Therefore I and double I are perpendicular to each other. Okay, so this one is a little bit lengthier. Okay, for 1 marks, this one a bit lengthier. So I have come with the idea of another way also. The okay, alternative method. The second method I would like to mention that. Okay, so this one is one method, and another method will be, so by just comparing these equations with ax squared plus 2hxy minus plus by squared. So from that you will get extract the value of a and b and use the condition of perpendicularity. Okay, now, so this one is the first method. Now if you have finished this, I would like to rub this and I would like to introduce the next method. Okay, for the same questions. Okay, so if you have finished, then that's okay. If you haven't, just take a screenshot and copy that later. Okay, now the second method. I think this second method will be more suited for the the 1 marks, because this will be asked in 1 marks questions. Okay, so the second method I would like to mention here. This is of the second methods, and the okay, second method. So in the second method, you just compare this. Let's suppose this equation I. Okay, now comparing I with ax squared plus 2xy plus by squared is equals to 0. When you compare this with this, now you will get the value of a3 and value of b is equals to -3, and at you will get, okay, 8 by 2, that is 4. So the pairs of lines represented by line I. Okay, the pairs of lines represented by the line I will be perpendicular to each other if the condition, use the condition of perpendicularity, if a plus b is equals to 0. So here in this case we have got a is equals to 3 and plus b we have -3 is equals to 0, or plus minus minus is equals to 0. 3 minus 3, that is equals to 0, which is true. So therefore the pairs of lines represent represented by line I are perpendicular to each other. Yes, because it satisfies the conditions. So I think this one, okay, I'll prefer this method. This is this the very first method is a little bit lengthier for the 1 marks question. So this one is more suited and it will consume less time. So yes, I prefer more the second methods. A very short Okay. Okay, now in the same way 5a also. In this case we have proved how to prove them, the lines are perpendicular. Now in this case, in the same way, we can do either of both methods. The first method, first you get the lines, okay, get all the lines, and then finding the slope and using the condition of whatever is been asked in the questions. And in the other method is the second method, comparing this, the given homogeneous equation, this single equations with ax squared plus 2xy plus by squared, and you will get the value of ab and x. Then after applying the condition of whatever is asked in the question. So this is how it is done. So if you have finished this, then it's okay. If you haven't, then I would like to rub this. If you haven't, just take a screenshot. So I'll move on to the number 5a. Okay, so without further delay, I would like to wrap this. Okay, now let's move on to the number 5a. Okay, so in 5a you have to prove the the lines represented by this. Okay, so here we have the equations of the singular equation we have given here, this. Okay, for this also I'll try to do by the both ways. So in the previous four number, we have to show the we have to show the lines are perpendicular to each other. But right now you have to show the lines are not perpendicular, they are coincident. Okay, so coincidence means it is the conditions are analogous to the parallel, because when the lines are parallel, the angle between them are 0. Yes, and coincident conditions also. And even in parallel lines the angle is 0. In the coincident condition also the angles is 0. So uh, the rules, the condition applied for both is the same. Okay, so let's move on to this. Okay, first we'll try to factorize this. Okay, the first method. So which one suits you? You just, this first method. First we'll try to factorize single equations. Given single equation, yes, I and z, single equation. The given single equation is 16x squared plus 16xy plus 4y squared is equals to 0. Try to factorize this. Now 16 times 4, it will be what we call that. It will be this 64. 4 6 18. 4 6 24. Yes, 64. That will be, so 64, and I think this will go into the a plus b whole square. Okay, so 16 you can write here 4x whole square, and this 4 will be 2y whole square. Now here 2 a and b. Okay, let's multiply this. 2 times 4, 8. 8 to the 16. 16xy. It is exactly in the form of a plus b whole square. Now this 4x will be the a and 2y will be the b. A square plus 2 a b plus b whole square. So you can write 4x plus 2y whole square. Okay, so this can be further written as 4x plus 2y and 4x plus 2y is equals to 0. Or you can either do, I have applied this, a plus b whole square formula. You can also factorize this in the same way. It doesn't matter, the answer will be the same. Okay, so here now we can do either 4x plus 2y is equals to 0, I, another also 4x plus 2y is equals to 0. So we have both equations same. So both equations same means their slope will also be same. Now slope of I, suppose this is m1, coefficient of x divided by coefficient of y. So here the slope will be here minus coefficient of x 4, coefficient of y we have 2, which is negative 2. Here also slope of double I m2, which is minus coefficient of x, coefficient of y, minus coefficient of x here 4 and coefficient of y 2. Okay, here will be negative 2. So they both have the same slope here. Since m1 is equals to m2 is equals to, both slope are equal, therefore the lines I and double I are coincident, coincident. Okay, the lines represented by the single equations, they are coincident to each other. Coincidence means they are overlapped, completely overlapped. Okay, so if AB is line, then another CD also completely overlaps into the same line. This is what I mean by coincident. Okay, so the condition for coincident and for the parallelism, those are the same. The condition applied for both of them are same, because the angle formed between those parallel lines and this coincident lines is same, 0 degree. Okay, so this one is the first method. So I'd like to introduce another method, the most easiest way. So I'm going to rub this. Okay, single equations. So we have single equations. Now this one. So if you have finished this, then it's okay. If you haven't finished, then you can rewind the video and just take a screenshot. Okay. And this one is the second method. And I prefer more this because it doesn't consume more time, just like I mentioned you earlier. Now this, suppose this is I. Now you compare equation I with ax squared plus 2xy plus by squared is equals to 0. Then you will get the value a is equals to 16, b is equals to 4, and x is equals to 2x is 16. Okay, so a, b, and x we have here. So these lines will be parallel. The lines, the pair of lines represent by single equation I will be coincident if x squared is equals to ab. Okay, so let's see. So x we have 8 squared, and ab we have 16, and b we have 4. So 80 squared we have 64, and 16 times 4 is also 64, which is true since the condition, since it satisfy the condition, therefore the pairs of lines represent by single equation I are coincident to each other. Yes, so we humans, we got the only thing we have is energy and time. So this math will conserve more time and energy, since it is a one marks question. So I think this math will be the better. Okay. So with saying this one are the very trivial one. In the next video we'll be continuing these. This one is a 1 marks question. I'll be continuing next time 2 marks question that is very short. This one is very short. Another will be short question answers. Okay, try to do that. All those which I haven't done, those are for you to do that. Okay, try to do all those. So this one is the basic one, very easy, and do not miss out the details. You have to go into that. Okay. So yes, so this much for today's video. So on next video we'll be coming back with the continuation of this video, the short questions, and until next time, take care, God bless, and take care of your health. And if you like my video, you can just share it to your friend circles if this video might be more beneficial. And don't forget to hit like and subscribe to my YouTube channel. Okay, so until then, goodbye, take care, and stay blessed.